Now let's talk about compiled programming languages. So generally, there's compiled programming languages and interpreted programming languages. Interpreted programming languages are like Python and JavaScript and PHP. You install an interpreter onto your system, whether it's Mac, whether it's Linux, whether it's Windows, and that interpreter reads a text file and basically in real time turns that into the application that you're using. Compiled programming languages are like the old school programming languages where you still type everything out in text. Basically, it's just ASCII text at the end of the day. But then you put that text through what is called a compiler. So C++ or C are compiled programming languages. And so what you do is you take the text that you've typed out, you put that through a compiler, and out the other side comes a machine-readable executable. So when you're looking at Windows and you see .exe files, those are generally created with a compiler. So basically, your code has been turned into something that's machine readable so that the operating system itself can directly interact with the program that you've created. Generally, compiled programming languages are considered faster than interpreted programming languages because you don't have to go through the interpreter level. And so for a lot of things, and that's where you'll see like C++ is used for a lot of real-time systems like robots and that types of things, because it's considered that a compiled program will run faster than something like an interpreted program. The issue that you run into with compiled programming languages, though, is that if you need to have the same application run on different types of operating systems, so Linux or Mac or whatever else, you will have to do something called porting the code that you've created. So the code that you wrote for Windows and C++ might not work perfectly on a Linux machine if you're going to run it. That, basically compile it, will not work the same necessarily on a Mac OS. And so basically you take your code, you run it through the compiler on a Windows machine, and that pops out a version for Windows. You then have to take your code, possibly modify it a little bit to be able to run properly on Linux, and then you put it through a compiler for the Linux machine, and then that will be able to run on Linux. You can put it through a compiler for a Mac OS machine, and then it will be able to run on a Mac. So that's one of the things with compiled programming languages is if you want to be able to use your code on different operating systems, you will have to port your code to the different operating systems. That's why you would have seen back in the day, it's been a long time now, but back when I had my computer repair company, QuickBooks had like 15 versions that would run on Windows. Right, they had all kinds of QuickBooks versions for Windows. They had the normal, they had like the standard version and the professional version and the nonprofit version, the factory version, the warehouse version, all kinds of versions. Right? For my clients that used Mac systems, they had one version. Windows had 15 versions of QuickBooks. Mac had one version of QuickBooks. And the reason is because they had to port the code to be able to run properly on Mac, and they just decided it wasn't worth enough resources to port 15 versions of QuickBooks onto Mac, so they only ported the one version so that it could run on a Mac. And so that's one of the things to consider when you're using a compiled programming language. So that's really all there is to the compiled programming languages. You write your code, you run it through a compiler for the operating system you're going to run it on. It pops out with the program, an executable that's able to run on that particular operating system. Is generally considered faster and more stable. It depends on what you've actually written, but you do have to port it to the different operating systems if you want the same code to run on different operating systems.